This problem's asking us to find all the zeros of our polynomial f, our polynomial function, if we're given one of the zeros. In other words, I'm given this big long polynomial here, right? I'm given one of the zeros, I need to find the rest of them. So what we're gonna do to find all those zeros is we're gonna take our normal polynomial and we're gonna take one of those zeros, all right, the one that they give us. We're gonna take the one that they give us and perform synthetic division on our polynomial. Okay, if you haven't seen my synthetic division video yet, you might want to watch that so you know how to do this, because I'm going to do it a little bit quick. Anyway, this one is not missing any of our terms. We're going to say this is going to be a 1, a -2, -21, and a -18. All right, and I'm going to start by bringing this down. 1 times -3 is -3. This is going to be a -5, +15. This is going to be a -6. -6 times -3 is a +18. And if this does not turn out to be 0 for this first one, you did it wrong because they gave us that 0. All right, so it absolutely has to be a 0, meaning there's going to be no remainder left. So again, this is going to be my number term, my x, and my x squared. So what I'm left with here is x squared minus 5x and then minus 6. Okay, and since we're trying to find the zeros, you could also probably say equals 0 in this case, just like that was one of the zeros. Now, we're going to first try to factor this. If that doesn't work, we use the quadratic equation or go from there. So let's see, does this factor? If I have my a term times my c term, that's -6. Two numbers that multiply to be -6 and add to be -5 are going to be a -6 and a +1, I think. All right, so let's write out those factors, x and x, and what I say, -6 and a +1. Yeah, that should work. All right, and then if I set those equal to 0 and solve here, this is going to be x equals 6 and x equals a -1. Those are two of them, as well as the one from the beginning that they gave us where x was also a -3. All right, so if I were to take and multiply those things back together, those factors of these three zeros, I would absolutely end up with my original one. Okay, this one was pretty easy. Let's see if we can try a harder one. All right, so this one is going to be a little bit harder, but at first glance, it's hard to tell the difference. So we just kind of have to work our way through it, and you'll see why it's hard at the end. All right, so we're going to start the same way. I'm going to take my -2, -2, and put it outside of my synthetic division box here. This one is not missing any terms, 3, 2, 1, none, so we're good to fill these in with 5, 12, 7, and 6. All right, bring down this first one. 5 times -2 is a -10. This is going to give me 2. 2 times -2 is -4. 3 times -2, again, is a -6. Again, this first time it should always equal 0 because they gave us that 0. They told us that that was what one of those was going to be. All right, left over, I'm going to have 5x squared plus 2x and then plus 3. Those are all positive. Real quick, does this factor? Let's see here. 5 times 3 is 15. My b term is 2. If I did a 3 and a 5, those are 2 apart from each other. However, if I made the 3 negative to get us to the 2, this would have to also be negative, and it's not. So because of that, I don't think that factoring can work on this one. So let me erase that. And instead, what I want to do is use the quadratic formula, all right, where this is going to be my a, b, and c. So if you remember the quadratic formula, I'll write it up here for us. It's going to be -b plus or minus the square root of b squared minus 4ac all divided by 2a, okay? So if I plug these in, -b for me is going to be -2 plus or minus the square root of b squared. 2 squared is 4. All right, oops, minus 4 times my a and c. A was 5, c was 3. 5 and 3, and this is all divided by 2 times a, which is 10 in this case. Okay, so let's do the math in the discriminant part here, the part underneath the square root. 4 minus 4 times 5 times 3. Well, 4 times 5 is 20. 20 times 3 is going to be 60. And 4 minus 60 is going to be a -56. All right, so we have -2 plus or minus the square root of -56 over 10. All right, you can start to see, I think, why this one is tough. Well, first off, we got to take an I out because of our negative. And then also the square root of 56. Well, 56 is divisible by 4. So instead of saying the square root of -56, I could say the square root of 4 times, I believe that's 14, or this is going to be 2 square roots of 14. You can simplify it a little bit. All right, if I simplify that, I'm going to just rewrite this. So now it's negative 2 plus or minus the I that we took out for the negative and the 2. So I'm going to say 2I root 14, all divided by 10. And then some of your teachers like you to leave it like this. I like to simplify a little bit further. The negative 2 divided by 10 can be a negative 1/5. And over here, 2 divided by 10 is just a positive 1/5. So I would probably write this answer as a negative 1 plus or minus, and then 1I, or just I, root 14 over 5. All right, again, that's 2 of my answers because one's plus and one's minus. Remember, the other 0 was already given to us up here. So you could also say x doesn't equal just these two, but x also equals a negative 2. All right, so if you found these videos helpful about finding all the zeros of a polynomial function, if you'd hit that like button, I'd appreciate it, and we'll see you in the next one.